Hey, what's up, folks? Dat from Arise here. Just wanted to put together a quick kind of introductory video into OpenTelemetry. I think it's a subject that maybe a lot of folks in the LLM kind of observability space kind of want to know more about, but really haven't heard about it or kind of used it in the past. I know myself, I didn't hear about OpenTelemetry till kind of somewhat recently. So I thought this would be a really great introductory into, what is OpenTelemetry, why does it matter, and how does that, what does that mean for us in the LLM observability space? So maybe to kick us off, I'll start with a little pop quiz. So what does the word telemetry mean? And so, I got this from Wikipedia, but telemetry is essentially the collection of kind of data at, you can think, some point or process. And the real purpose behind telemetry is just so that we can monitor kind of what's happening in some process or something. So in the physical world, it might be things like transmissions on animals, like here, kind of this saltwater crocodile with the GPS satellite on it, or maybe some other pieces of tooling that go into some process and is just tracking data. So just wanted to cover the basis of what telemetry even means, and then next I want to get into what does OTel mean, or open telemetry. So those are kind of synonyms, but open telemetry is kind of the standard for thinking about monitoring and observing, you can think, software for the last 10 years. And it's extremely popular. And maybe the reasons for that are, one, you kind of own the data that you're generating or that's coming from your process. And so you're not reliant on some vendor-specific way of doing stuff. You can think of OpenTelemetry as the standard for collecting telemetry data, for instance, in a software process or an LLM process. And the other added benefit is that to the consumer or the person kind of who wants the telemetry data, it's actually better for you. You only have to learn maybe a single set of conventions, APIs, etc., but it's kind of a standard framework. And so this is good because if you ever wanted to switch to some other, you can think, vendor who is also OpenTelemetry compatible, it's actually better for you. You don't have to change as much in your production level code. You don't have to change up a bunch. You're not too tightly coupled to doing something some vendor specific way. So again, OpenTelemetry is super popular in the software world, has been the last 10 years, pretty much the open standard. And so maybe to build intuition for the folks who are just kind of brand new, they've never heard of the word OpenTelemetry, I always like to start off with a metaphor in the physical world. So take, for example, imagine you are some manager at some factory, let's call it the Tesla factory, where you have a lot of complex processes where things can go wrong or slow down, or maybe you just want to observe, hey, how do we improve stuff over time? And so maybe the question is hey, if I have some process, how do I figure out how to improve things over time or catch when things kind of go wrong? And so maybe in the physical world, you might, choose some process, maybe a manufacturing line, or choose a set of processes. And then what you might do after that is set up some cameras, right? And so these cameras will be set up so that you can, send the feed to some central place or server where you can track this stuff, look at it in real time, or maybe come back and look at the recordings. And of course, if you're looking at these recordings, there's some nice UI where you can play stuff and choose whatever you want to look at and, play back or look at stuff live. Great. So in the software world, right, things aren't actually so different. So maybe in software, we can think instead of some large factory, maybe it's just some microservices architecture or some software application, some repo, for instance, where some work is happening. And so that would be the process. And then maybe setting up the camera would be more akin to, in the OTel world, of instrumentation, which is basically adding some code in your code to kind of track and monitor and collect telemetry data in that specific process. And then, of course, that data has to be sent somewhere, right? So we have things like exporters to export data. We have collectors to go and collect that data because maybe some of that data is coming in, asynchronously. Maybe there's different parts coming in. And then, of course, we need some sort of UI. So this is human friendly, right? So that think, a traces view set. So if you've ever used Datadog or AWS X-Ray, Google Traces, Honeycomb, they all have some really nice UI to be able to say, hey, here's some software process that's happening, and we can see how long things take and if something broke, etc. So that's a really good kind of metaphor into OpenTelemetry and the purpose. And the purpose, you can see, is quite valuable, right? There's a lot of really great engineers that really do rely on OpenTelemetry and just observability. You can think that this is like APM or application, kind of observability. And so there's some pieces inside of OTel that we'll talk about. I won't go into too much depth since this is kind of like an intro course, but you'll have things like, some client that might be, exporting traces, collecting traces, exporting them out somewhere. Of course, receivers will receive those kind of traces. Maybe specifically in this video, we'll talk about OTLP or OTel kind of protocol, just collecting traces. Processors, we won't get into much depth, but it's really, you can add some really nice custom logic to do stuff like filtering traces or some other things. And then we can obviously export traces. So the really cool thing is it's not just like, export here, send to here, and you're done. You can actually export here, send to this thing, do some logic, send to some other thing. So if you had things like kind of distributed services or things that are a little bit more complex, you can get a little bit more fancy. And then, so that's kind of like some examples of like some, core OpenTelemetry pieces. And, just remember that telemetry or OTel was really built around complex processes. So maybe you have different paths or parallelization in processes, or maybe it's distributed, or maybe asynchronous processes are happening. It's all possible to capture this data with OTel. So it's a really nice paradigm. And so really for the talk today, I just wanted to go into what does this mean for the LLM space for folks building. So we know this is a very popular space. LLMs are everywhere. And what does observability really mean for maybe a complex agent workflow, or maybe some hand-rolled, custom-built Gen AI application? And so it's not too far from software, actually. So in the same way we would choose some sort of microservices architecture or kind of software process, it's kind of the same. Maybe that process is maybe a lane chain. Maybe it's a Llama index workflow. Maybe it's something you built yourself. But the whole idea is now we've kind of abstracted, it's basically still software, but now it's some LLM specific process. And so in this particular example, for setting up the camera, we have instrumentation, and we're going to set up the instrumentation in this example with Arise's Open Inference, which is, I'll go into depth, but it's compatible with OTel. It's actually built on OTel with some extra goodies. And so that's how we'll talk about some instrumentation. And then we actually, use the same OTel exporters and collectors to go in and grab that data. And then, of course, instead of some, APM or, application performance monitoring application, it's more centered around LLM observability. So things like collecting traces, looking at prompts, going to prompt playground, collecting data sets. So more centric LLM workflows like that. And so you can think of, OTel and LLM observability as kind of, this is a good way to describe it. It's not far from software engineering, actually. And so, just a little bit about Open Inference. So it is you can think library. It was built on the foundations of OTel. So it's essentially OTel, but we've added some extra, you can think LLM kind of goodies, call them semantic attributes, or really things that it's data that you want to collect that's kind of standard to LLM applications. And this is really important because as you go through workflows like, troubleshooting or root causing or experimenting to see if, hey, how can I make things better? We're kind of automatically collecting that data for you so that these workflows kind of just happen. So there's some technical words that you might get introduced when you first start learning OpenTelemetry, but don't worry about them. It's not too crazy of a foreign concept, but some of the things you might hear is like a thing like a semantic convention. Really, the semantic conventions in OTel, for example, are really the standard fields and kind of attributes, or really just fields and markers to say, hey, these are what we're calling the span start time and the span end time, so that whenever it's essentially the standard, right? So when you have a standard, you want things to be standardized. This is essentially the standardization. So hey, these fields mean these things. Of course, in Orize's Open Inference, same thing. We have some semantic attributes that are native to Open Inference, and it's really like, hey, this is the LLM input or the LLM output, or this is an embeddings call. So we've kind of standardized in the LLM space as well. So when you hear stuff like semantic conventions, that's really what it means. It's just a convention that pretty much folks are using so that everybody has the same kind of definition of things. So when we're instrumenting kind of an application, right, remember that we're kind of setting up a camera to look at some process and pulling out the data. And really, I just want to give folks an idea of what we're pulling out. So these are examples of like span data that we're pulling out for, and I'll go into depth of what a trace and a span is. But essentially what a trace is I'll show a real example. Traces and spans, another set of words. A trace, you can imagine, is what you've defined as some process. So for some folks, it might be a single call to a chain or a single call to a workflow. And a trace looks like this. It's a collection of spans, right? And a span, you can imagine, is maybe it's your definition or some logical definition of a piece of work, right? So a trace is a collection of spans. Spans can include many different types of work. Maybe one of the spans is an LLM call. Maybe one of the spans is, an embeddings call, for instance. Maybe one of the spans is some sort of re-rank, for example. But a trace, you can imagine, is some larger process and made up of like logical units of work or processes called a span. And so when we look at what span data is coming from, like what span data looks like coming from instrumentation, or in this case, this is open inference instrumentation, it's really just like a set of it's like a JSON. So it's a set of keys and values. And this gets collected, so it gets emitted and collected by some endpoint so that we can do something valuable with it. So just wanted to give you folks an example of what span data looks like, or OTel or telemetry data looks like. So I won't go into too much depth about instrumentation, but instrumentation can be tricky for some folks if they've never done it before. But you'll have a lot of useful things that you don't have to always use some sort of manual way to instrument the data or setting up that camera, if you will. For instance, Orize Phoenix has a bunch of kind of integrations built out. So you can imagine, I'll take the lane chain example. So inside of lane chain, there's kind of this callback manager. It's kind of this thing that coordinates everything, knows what's happening. We essentially, since it's open source, we essentially take that, convert it to telemetry data so that, you don't have to really go in there and add a bunch of lines of code to instrument anything. You really just add this kind of one line of code. And then you kind of have all the telemetry traces coming from that process. So whatever lang chain or llama index process that you've kind of chosen from whatever framework, there's a lot of, open source frameworks out there that are orchestrating these LLM applications. You can just add these one line, we call them auto instrumenters, and they just work. So for example, this is an example of that. We added one line of code that was that auto instrumenter for llama index. And then now we can see everything that's happening inside of llama index, for example. Of course, if you've hand-rolled your own code, you can, of course, instrument things manually. So actually the structure here, you can actually customize to whatever you want. So if you built your own classes, functions, methods, your whole repo for an LLM applications, you can actually just determine what this looks like. And it's not a this or that. You can actually mix in things like auto instrumentation. So if you use llama index for these parts and then hand-rolled something else, you can actually capture everything with the auto instrumenter here and then manually instrument kind of the rest or add some custom instrumentation. But it's actually not that hard. Maybe as you first go through it, you might learn some kind of nuances, but that's an example of kind of the overview of maybe OpenTelemetry and kind of why it matters in the LLM space. So there are some really awesome references. Of course, I'm going to plug Arise Phoenix has a lot of these examples, and Arise Phoenix is completely open source, so feel free to give it a try. We have a bunch of examples kind of already coded up for you. So if you ever have, your own, you built kind of like an example application and you're using one of the major frameworks, it's actually super easy to get started. But I just wanted to put out a quick primer on what OpenTelemetry is, because I know myself, I didn't hear about it till I started getting really deep into the space, and I just wanted to educate other folks who've maybe never heard about it, to give them kind of an introduction into it. Maybe I'll put out a later video about more advanced OTel patterns that we're seeing from the LLM space. But thank you so much, and I hope you enjoyed it.